All right, welcome back to another episode of Math with Mr. Young. So today we're going to be working with 8.8, solving inequalities. Our standard is 6th grade numbers in C, and our objective is that we're going to be able to write and solve inequalities. Our mathematical literacy, we have inequality, addition, subtraction, multiplication, and division property of inequality. All right, with lesson 8.8, solving inequalities, our success criteria is that we're going to be able to apply the properties of inequality to generate equivalent inequalities. We're also going to be able to solve inequalities using addition or subtraction and solve inequalities using multiplication or division. We're also going to be able to write and solve inequalities that represent real life problems. All right, for mathematical literacy, we have inequality. Now, inequality is a mathematical sentence that is used to compare quantities, and it also contains one of these signs. So the first sign that we have here, is A is less than B, okay? A is less than B. So whatever the quantity of A is, it is less than B, okay? And this is not a solution. So that's why you have an empty circle, all right? So it has an open circle, which means it's not a solution. We'll talk more about that. So the next sign we have is A is greater than B. So this is, if you ever see this here, A is greater than B, this is what it's saying. A is greater than B. And again, it's an open circle, okay, because it's not a solution. As we go further down, A is equal to B, which is why you have an equal sign. A is not equal to B, so there's like a slash through the equal sign indicating that A is not equal to B. Further down, A is less than or equal to B, and that is a closed circle. Anytime it's less than or greater than, or less than or equal to, or greater than or equal to, that's what we mean. So right here, A is less than or equal to B. So this means A is less than B, or A is equal to B. Okay, that's what it's saying there. Now as we go further down, we have A is greater or equal to B. And again, a closed circle there. So A is greater than or less than B, or greater than or equal to B, I mean. So that means that A is greater than B, or A is equal to B. All right, so that's what that means. Now, when we have these signs, here's an example. Let me see. Let me move it down just a bit. So down below, I have this symbol, okay? Now, on the where this mouth opens up, I mentioned that's a coyote mouth, that open side. And then there's that point, a vertex side, okay? On the open side, this is the greater value, okay? On the vertex side, this is the lesser value. All right, so let's make sure we know that. And we're going to continue. And so when we graph these inequalities, okay, 0, 1, 2, so on and so forth, or opposites, -1, -2, so on and so forth. When we graph these, let's say, for example, if we were graphing A is less or greater than or equal to B, so we have, let's pretend that we're going to graph it here. So we're going to have, I'm going to circle 1, and I'm going to color that in because it's less than or equal to B. So what if B was 1, and whatever A is has to be greater than 1. Greater than 1 or equal to 1. All right, so that's where the all these solutions, these possible solutions, an infinite amount of solutions, all the way to positive infinity go. All right, so that's what that means. Now, we're going to go ahead and continue with our mathematical literacy. All right, to continue, we have 4 different properties here for inequality. We have the addition property of inequality, the subtraction property of inequality, the multiplication property of inequality, and the division property of inequality. So again, addition, subtraction, multiplication, and division. All right, oops. Let me make this smaller actually. division. There we go. All right, now we have two columns. On one column, we have numbers. The second column, we have algebra. Now, let me give you guys an example using the addition property of inequality. Okay. So for the first thing we want to talk about with the addition property of inequality is that when you add the same number to each side of an inequality, this inequality remains true. So for an example, using just numbers, numerical, okay, numerical. So if we have 3 is less than 5, okay, so that's the numbers there. 3 is less than 5. That's going to be basically what we want to do. Let's say adding 2 on both sides of the inequality. Okay, so 3 plus 2 equals 5. 5 plus 2 equals 7, and that remains true because 5 is still less than 7. Okay, so algebraically, if I have x minus 4 and that's greater than 5, okay, algebra, when we have algebra, we basically have alphabets in the numerical expression or numerical equations. Okay, the only difference is we have an unknown value. So if we have a negative 4 here, we're going to add 4 to both sides of that inequality. Negative 4 plus 4 is 0, so this cancels out. Okay, x is by itself, all right, and 5 plus 4 equals 9. So whatever x is greater than 9. So that's what that means, all right. And just remember that when you add the same number to each side of an inequality, that inequality remains true. Just like the subtraction property of inequality. Whenever you subtract the same number from each side of an inequality, the inequality remains true. For an example, if we have 3 is less than 5, and we subtract, instead of adding 2, we subtract 2 from each side of the inequality. 3 take away 2 equals 1. 5 take away 2 equals 3. Still, 1 is less than 3, so that remains true. And algebraically, if we have x plus 4, and that's greater than 5, and here's the reason why we're saying subtraction property of inequality, because we subtract 4 from each side of the equation, or the each side of the inequality. Positive 4 take away 4 is 0. X is by itself. 5 take away 4 equals 1. Okay. Again, whatever x is, it's still greater than 1. All right, so that remains true. Now with the multiplication property of inequality, okay, with this one, same thing. When you multiply each side of an inequality by the same positive number, the inequality remains true. For an example, numerically, if we have 8 is greater than 6, and if we multiply just for fun by 2, 8 times 2 equals 16, that's still going to be greater than 6 times 2 equals 12. So that remains true with the multiplication property of inequality. Now algebraically, if we have, let's say for an example, x over 4, and that's less than 2, okay, and if we multiply by 4, okay, so that's basically like saying times 4 on both sides. Okay, this cancels out. X is by itself. 2 times 4 equals 8, and that's still true. X is still less than 8. Okay, and lastly, the division property of inequality. Okay, division property of inequality. So if we have, let's say 8 is still less than 6, and just remember that when you divide each side of an inequality by the same positive number, the inequality still remains true. So if we divide by 2, okay, 8 divided by 2 is still going to be less than 6 divided by 2. 8 divided by 2 is going to be 4, and 6 divided by 2 is going to be 3. So 4 is still greater than 3. Algebraically, And all we're doing is throwing in a variable with an unknown value. Let's say we have 4x over 4. That's still going to be less than 8 over 4. Okay. Again, when you divide each side of an inequality by the same positive number, the inequality still remains true. Now, 4 divided by 4 equals 1. That cancels out. X is by itself. 8 divided by 4 is going to be 2. Again, x is still less than 2. All right, so that's basically it. Hopefully it was straightforward. Talking about the addition, subtraction, multiplication, and division properties of inequality. All right, with our first example, we're going to solve inequalities using addition or subtraction. Now let's read the problem and the directions. So the problem is that we want to solve x minus 3 when it's greater than 1 and also graph that solution. So for this one, we're going to use the addition property of inequality. Okay, so we wrote the inequality. Next, we're going to use the addition property of inequality. So since we have x minus 3, we're going to add 3 to each side of the inequality. Negative 3 plus 3 equals 0. X is by itself because that cancels out. And 1 plus 3 equals 4. So now we have x is greater than 4. Now we have to graph that on a horizontal number line or a vertical number line, just whatever your preference is, okay? So, because if you look at the symbol, it's less or greater, x is greater than 4. It didn't say that x is greater or equal to 4. So that means that when we have, see, negative 1, 0, positive 1, positive 2, positive 3, positive 4, so on and so forth. So we locate 4 on the number line, positive 4. I'm going to put a open circle there because that is not a solution. Now remember that whatever x is has to be greater than 4. So numbers that are greater than 4 are 5, 6, 7, 8, so on and so forth to positive infinity. The possibilities are infinite. Okay, the solutions are infinite. Okay. So there you go. You, my friends, just graphed the solution and the inequality of x is greater than 4 on the horizontal number line. Now for B, again, we want to solve here. We want to solve, and we see that 15 is greater or equal to 6 plus h. And we're going to graph the solution. So with this one, all we're going to do, okay, so if we have, if we have 6 here, we want to isolate the variable h. So if we're going to go ahead and add, okay, we're going to, we're going to subtract. The opposite of addition is subtraction. So we're going to use the subtraction property of inequality, subtracting 6 on each side of the inequality. 6 take away 6 is 0. That cancels out. H is by itself. Okay, rewrite the greater than or equal to symbol. Now 15 take away 6 is going to be 9. So now our solution, simplified solution, is 9 is greater or equal to h. Now all we have to do is graph it. I'm going to choose the horizontal number line. Okay. So let's say that, let me go with 0 here. I'm going to go in multiples of 3. Negative 3, negative 6, negative 9, positive 3, 6, 9, 12, 15, 18, so on and so forth, okay? Now, I want to locate positive 9 on the number line. Well, there it is. So I'm going to put an open circle there. But we have a greater than or equal sign. So I had to color this in. I want to shade it in with a solid color, okay? Now again, 9 is greater than h, okay? So greater than or equal to h. So whatever h is, it's less than 9. So h is less than or equal to 9. It could be 9 or it could be less than 9. Now we look at all the integers on the number line that are less than 9. All these positive integers that are less than 9, and the infinite amount of negative integers that are less than 9, all the way to negative infinity. There you go, my friends. You have just solved and graphed the inequality on the number line. Again, this is going to be 9 is less than, or sorry, 9 is greater than or equal to h. All right, using the same concepts of what we did with the last examples, this time we're going to be solving equations. We're going to solve inequalities using multiplication or division. So we have two examples here. So we're going to solve first and then graph the solution on a horizontal number line. So we're going to solve x over 5 divided, or sorry, let me start back over. We're going to solve x over 5, and that's less than 2. Okay, so since we're dividing here, we're going to multiply. Okay, so let's say that we have x over 5. We're going to multiply by 5 on each side of the inequality. 2 here, so 2 times 5, okay, because your denominator is 5. Now these two cancel out. X is by itself. 2 times 5 equals 10. So here we are. There's our simplified inequality, using the multiplication property of inequality to solve. Next, we're going to have to graph this. So here's my horizontal number line, your x-axis. Let's go ahead and call this, let's say, 0, okay, 2, 4, 6, 8, 10, 12, 14, 16, 18, so on and so forth to positive infinity. Negative 2, they're opposites. Negative 4, negative 6, so on and so forth to negative infinity. Now, since we're going to graph this here, we know that whatever x is less than 10. So since it's just a less than symbol, it's going to be an open circle. So let's find positive 10 on the number line. Right there's positive 10. So we're going to have an open circle, okay? And then from there, we're going to go ahead and graph. Now remember, the x values have to be less than 10. So if we look at 10 here, everything less than 10, we're just going to shade that in. There we go. And my friends, you have graphed x is less than 10 on the horizontal number line. Okay. And lastly, we want to solve and graph for n, and this is going to be greater than or equal to 32. So right here, just looking at the inequality, we have to use the division property of inequality because we're multiplying. You have a coefficient 4 and a variable n. That tells you need to multiply. So we have to do the inverse operation, which is division. So we're going to divide by 4 on both sides of the equal sign, or the inequality. 4 divided by 4 equals 1. N is by itself. Okay. 32 divided by 4. 32 divided by 4 is going to be 8. Okay. Now we're going to get your horizontal number line, your x-axis, and let's call this 0, negative 2, positive 2, positive 4, 6, 8, 10, 12, 14, 16, 18, 20, so on and so forth to positive infinity. Now again, because it's a greater than or equal symbol, it has to be a closed circle. So let's locate 8 on the number line. Positive 8 on the number line. There it is. Here's a circle, and I'm going to color it in. Now remember that n is greater than or equal to 8. So whatever these numbers are, it has to be greater than 8. Okay. So if we look, all these numbers to the left of 8 are, all the numbers to the left of 8 are less than 8. All the numbers to the right of 8 are greater than 8. So we're going to color in to the right. And there you go, my friends. You have just graphed n is greater or equal to 8 on the number line. All right, with this next example, we're going to solve an inequality using a reciprocal. So we're going to use a reciprocal here, okay? Now we're going to solve 2x divided by 3, and that's greater or less than or equal to 4. And then we're going to graph that solution. So first thing we want to do is write the equation, which we already did. Let's just do it again. 2x over 3, and that's less than or equal to 4. So we wrote the equation. The next thing we want to do is rewrite this equation. So we rewrite this as, well, we had to get the reciprocal by multiplying each side by the reciprocal of 2 over 3. So use a different color. We're going to multiply here on both sides of the inequality. So 2 over 3. If we reciprocate it, 2 over 3 becomes 3 over 2 on both sides of the inequality. Now, 3 times 2 equals 6. 2 times 3 equals 6. 6 divides into 6 one time. So, meaning this cancels out. And x here, your variable, is by itself. All right, so we isolated a variable by using reciprocation. Less than or equal to 4. Now, we changed the whole number 4 into a fraction by putting a 1 underneath of it. Now, 4 times 3 equals 12. 1 times 2 equals 2. Half of 12. 12 divided by 2 is going to be 6. Okay. So again, just to recap, we wrote the inequality and we rewrote it using the reciprocal. Okay. And then we also went ahead and used the multiplication property of inequality, and we simplified to x is less than or equal to 6. Next, we have to graph the solution. Here's your x-axis. Here is 0, positive 2, 4, 6, 8, 10, 12. I'm going to go in multiples of 2, okay? And then opposites, negative 2, negative 4, so on and so forth. Now, notice that this is a less than or equal to sign. So that means that it's going to be a closed circle. Let's locate 6 on a number line. Positive 6 here. And it's going to be a closed circle because it's less than or equal to. And then we got to look at it. All the numbers that are less than 6 or even equal to 6, we're going to shade. So it goes to the left because all the integers to the left of positive 6 are less than 6, including 6 itself because it's equal to 6. And there you go, my friends. Using reciprocation and the multiplication property of inequality, we have simplified and graphed that inequality. All right, for our last example, we're going to model real life. Okay, so I'm going to read to you guys in verbatim. Now, a one-way bus ride costs $1.75. Okay, a 30-day bus pass costs $42. When is a 30-day pass a better buy? Okay, so we have to understand the problem. Just know that we're given the cost of a one-way bus ride and also the cost of a 30-day bus pass. And we're asked to determine when the bus pass is a better deal. So we had to make a plan. So for the pass to be a better deal, just know that the total cost of a one-way bus ride needs to be in a 30-day period. Okay, and it must be greater than the cost of the pass. So we could use a verbal model to write an inequality, and then we're going to solve the inequality. So let's use a verbal model. First of all, let's say we had to understand the cost of a one-way ride, and that's in dollars. We also have to and we're going to multiply that, by the way, times the number of one-way rides. And that should be greater than the cost of a 30-day bus pass. Again, in dollars. So that's what we need to understand about this situation here. Now, if we let R, because of ride, okay, we're looking for a ride here, the bus ride. So if we let R be the number of one-way rides, then we know that the cost of a one-way bus ride is going to be $1.75 times the number of rides. We don't know, so that we use a variable R, and that's going to have to be greater than the cost of a 30-day bus pass, which is $42. 42. Okay. So now we solve. Okay. So we have 1 in 7,500 times R, and that should be greater than 42. So again, here, the opposite of multiplication is division. So we're going to have to write and use the division property of inequality. So we're going to divide here. So this is going to be 175R. Okay, so it's going to be looking like this. 1.75r, that's greater than 42. I just rewrote it in here. Now, 1.75 is your coefficient, r is your variable. So we divide it because it's the opposite of multiplication. We're going to divide by 1 in 75 hundredths. 1 in 75 hundredths divided by 1 in 75 hundredths equals 1. So r is by itself. Okay, let me move this down. All right. Now 42 divided by 1.75, if I were to work that out, move this decimal point over twice, move that over twice, annex zeros there. Now 175 can go into 4200 about 24 times. That's 4200 at 0. So this is going to be 24. So r is greater than 24. Okay, so we simplified. There's our inequality. Now, that's basically it. So we can say, so the 30-day pass is a better deal when you take more than 24 one-way rides in a 30-day period. So yes, you do have to invest in that bus pass, but to get the most, or to make your money back and make your money's worth, you do have to take 24 bus rides to buy the pass. So the pass is a better deal. Okay, so that's basically it, guys. Solving inequalities with 8.8. So that's, in a nutshell, is what we're going to be doing. Easy peasy lemon squeezy. Now for 8.8, solving inequalities, by now you should be able to apply the properties of inequality to generate equivalent inequalities. You should also be able to solve inequalities using addition or subtraction or multiplication or division. And you should also be able to write and solve inequalities that represent real life problems. Now remember to always ask questions, ask your teachers for help, ask questions. And if you ever get stuck in mathematics, always look for a pattern, try things out. Find a way. There's always a way out. There's always a solution. Okay? Well, we'll see you guys later. Don't forget to attend tutoring. And again, ask for help if you get stuck.